Good morning, guys. All right, guys. Hope that everyone is doing all right. The chapter number 1 in our Math 30-1 course is called Transformations. So, transformations being is like if we have some general function, so it could be a quadratic function, could be a cubic, could be a radical, could be a rational, could be a trig function. So, any type of function that we want. And how can we modify those functions for certain purposes? So when we say modify it like that, we're talking about different types of transformations that could happen. So in this unit, the transformations that we're going to talk about are what we call horizontal and vertical translations, which means we're shifting the graph up and down or side to side. We could have a vertical or a horizontal stretch. That means we're kind of pulling the graph and make it kind of stretched, either in the vertical direction or the horizontal direction. We could reflect the graph, which means we're going to reflect it in either the x-axis or the y-axis. So it'd be kind of like a mirror image of the original graph. And we could do something we call the inverse of the graph, which means for inverse means we're going to be switching the x and the y axis. So those are the topics in the transformations unit. And the first topic is going to be called horizontal and vertical translations. And I'm just going to get into this one. All right. So what we see here is, first of all, guys, this program is called Desmos. Okay, so Desmos is a free online graphing software, and really, guys, it's awesome. I really wish that we were allowed to use this one for you guys to have for tests and stuff like that, but unfortunately, this is not an approved resource. And the reason is because, like, well, you can access this on your smartphone, but that means you could also access everything else on a smartphone as well. So what we have here is just don't worry about this stuff over here. There's kind of restriction on the domain, but we have this function called the absolute value of x, which is going to give us this V-shaped graph over here. Now I kind of restricted it only from x values from -3 to 4, and this is our f of x. So what we see for g of x here, g of x is going to be a transformed function with f of x as a base function. So what we're saying here is saying we have f of x minus h. That's this part right here. And then we have this plus k part right here. So what we're going to learn about today is what do the h and the k values do for our absolute value function. So right now, currently, I have h and k set at 0. Okay, so in other words, it's just so currently g of x is the exact same thing as f of x, and you'll see that right over here. If I start modifying if I switch my k value and switch it to 1, okay, now what you'll see here is that this graph is identical to the red graph, but it's just been shifted 1 unit up. Okay. Other things we're looking at here. So if you look at this point, 4, 4, and this point, 4, 5, well, they have the same x value, but you'll see that the y value is 1 higher. And for all these corresponding points, like 2, 2, 2, 3, 0, 0, 0, 1, 3, 3, negative 3, 3, negative 3, 4, the x values all remain the same, but the y values are now 1 higher. So if I make k 2, that means the graph's been shifted or translated up 2 units, and so forth. So if I modify k, if I make k a negative number, like -1, this means that our graph is going to be shifted down 1 unit, and so forth like this. Okay, so the point that we're trying to get up for the k value here is it's going to be the same exact shape of the graph, but it's going to be translated, and we call this a vertical translation. So this over here would be a vertical translation of 3 units. That means for all of my original points, I'm adding 3 units to the y value. So this 4 becomes a 7, this 2 becomes a 5, and so forth like that. So this is what we talk about when we consider a horizontal translation. Sorry, a vertical translation. Now for h, this is going to be the horizontal translation. So if I start moving this h value, and that's going to be affecting this number in the equation over here, well, this graph is going to start moving left and right. Okay, so if k is negative, the graph is going to move to the left. If h is positive, the graph is going to move to the right. Okay, so that's going to how this works. So, guys, hopefully this makes sense. Hopefully this makes sense. And a sec here. There we go. So we're talking about this. Describe what the parameters h and k do for the functions. This k value. So if I ever have a k value here, is what we call a vertical translation. So we can put it back here. This shifts the graph up or down. Okay. All right. What does this h value do? This h is a horizontal translation. All right. So the k value is going to be a vertical translation. The h value is going to be a horizontal translation. All right. So what we have over here, and like I said, guys, this unit is, it doesn't matter what the function is. Okay. So in this case, we have f of x is x cubed. Okay. So x cubed is this cubic graph, and this is how it looks over here. So in other words, if x is -2 times -2 times -2 is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1, and 2 cubed is 8. Okay, so we can give you 5 points. So if I'm doing a of x over here, well, this is saying f of x minus 3. So what this -3 is telling us is that this is going to be a vertical translation of -3 units. So in other words, this is going 3 down. So if I look at all 5 of these points, this point is going to go 1, 2, 3 down and be left here. Okay, this point here, -1, -1, is going to go 3 units down. So the point is, guys, we're going 3 units down, but we're not going left or right. So all this is affecting is the y value and taking all these points and going 3 down from where they were. Okay, so this graph is going to look like this guy over here. And I'm going to call this guy a of x, like this. Okay, all right, so what's f of x plus 2 going to do? This is going to be the same idea, except it's going to move our graph 2 units up. So this is a vertical translation of 2 units, which means 2 units up. So this point is going to come up to 10. This goes up to here, up to here, up to here. And this graph is going to be like this. And this is going to be our b of x graph. Okay, here's where it gets a little bit confusing. What we saw in the previous example is that in this case, what we talked about is the horizontal translation is in this form over here, f of x minus h. So if I have f of x minus 5, this is saying if the form is x minus h and I have x minus 5, therefore h equals 5. So this means a horizontal translation of 5 units. Okay, over here. So it gets a little bit confusing. Even though this says x minus 5, this means we're going 5 to the right. So I'm going to put this in brackets here. This means 5 right. So that means this point goes 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and so forth, like this. So this graph is going to look like this. This is c of x. Okay. Now for d of x, this graph is going to be a horizontal translation of -4 units. Okay, so we'll talk about this in a bit more detail. So like we said before, the horizontal translation is always in the form x minus h. Well, this is not in the form f of x minus h, it's x of x plus something. So if I write my d of x function really what's the same thing as x minus -4. Okay, so if you look at it this way, so now this is in the form of f of x minus h. My h value is actually -4, and that's why it's going to be a horizontal translation of -4 units. So that means we're taking this graph and we're moving it 4 to the left. So 1, 2, 3, 4 here. 1, 2, 3, 4. And all of these points are going 4 to the left. And that's going to be this guy over here. So this is our d of x graph here. All right, guys, so hopefully that makes sense for how these translations work. So let's move on to the next example. So here's something's a little bit confusing over here, okay? So we have something we call function notation over here, okay? So this is saying horizontal translation of h units, and this k is telling us vertical translation of k units. Okay, now here's what gets confusing. So if I have y equals f of x minus 7, this 7 is telling us 7 units right. Okay. Now what the mapping notation says, it's going to say literally what's happening to every point. If I'm going 7 units to the right, that means whatever my existing x values are here, I'm adding whatever that h value is. So in this case, even though it says x minus 7, in this form, my h value is 7 over here. So that means we're going 7 to the right. Now the k is nothing too confusing here. If I'm going up or down, whatever my k value is, it's going plus k. Now I know it says pluses in both of these over here, but if k is a negative number, well, say k was like -3, that would be like y plus -3, which is the same thing as y minus 3 over here, okay? So this k value is going to be added to the y values. This h value is going to be added to my h values, okay? So this is what we call mapping notation and then function notation over here. Okay, example 3. Describe in words, mapping notation, and in function notation, how the function is transformed to become g of x. Right, so first thing, in words. Really what we're doing here, actually I'm going to change my mind. I'm going to do function notation first. So for function notation, here's function notation. So what I've done is, compared to my f of x, I've replaced this x with x plus 4. So that means it's x plus 4 like this, okay? So here's in function notation. In words, this is a horizontal translation of -4 units, which means a shift 4 to the left. Okay? All right, so here's the words. Okay, here's the function notation. Let's talk about mapping notation. So what mapping notation is going to be is we're going to write, so this is xy. So this is like xy on some point over here, okay? And this is going to be on my y equals f of x, right? Now, if this guy becomes y equals f of x plus 4, which is what this is, that means that all of my x values are being shifted 4 units to the left. So in the mapping notation, I'm going to write this as x minus 4. no effect on my y values over here. Okay, so my x value is going 4 to the left, so this is a mapping notation, but in the function notation, it's going to stay as x plus 4, like this. And this plus 5, sorry guys, I totally forgot about this. This plus 5 is over here. So I can put, this is part of the words over here, and a vertical translation of 5 units, which means 5 units up. Okay, so back to this one over here. This is x plus 4 plus 5 like this. So here's my mapping notation. That means I'm adding 5 to my y coordinates here. Okay, so example 4 says the point A, it's this guy right here, is on the graph of y equals f of x. So this is some graph y equals f of x. Determine the image point of if y equals f of x becomes y plus 6 equals f of x plus 1. So first thing I'm going to do is the transformations that we were talking about look in this form over here. So in this case, this 6 is kind of on the wrong side of the equation. So I'm just going to rewrite this guy as y equals f of x plus 1. And I'm going to put this minus 6 over here. So I just subtract the 6 from both sides like this. Okay. So really what's happening here is this x plus 1 is saying we're going 1 unit left. Is a horizontal translation of -1 units. And then this is telling us we're going 6 units down. Okay, so if I'm taking this point as my A, if I go 1 unit left and then I go 6 units down, it's going to take me to here. Okay, now often like that, if we call this one point A, we're often going to call this one A prime. Okay, so this is like the image point. So what image point means is the point after the transformation. So if this is the original point, A prime is the image point, which is the point after the transformations have happened. So this guy over here is 1, -1. Okay, so given the graph of y equals f of x, sketch the graph of y equals f of x minus 3 minus 4. So what's happening here is that, let's look at our mapping notation. F of x minus 3 tells us that we're moving 3 to the right. Okay, so remember, if there's a minus inside the brackets like this, so that means for our mapping notation, we're going x plus 3. This is 3 to the right. And this minus 4 means we're going 4 down. So it means we're subtracting 4 from our y coordinates. Okay, so this is our mapping notation for this guy. So all I'm going to do for each point over here, I can go 3 left, 4 down. 1, 2, 3, 1, 2, 3, 4. Okay. 1, 2, 3, 1, 2, 3, 4. Okay. This point goes 1, 2, 3, like this. So far we have a graph that looks like this. Okay. Now for this one, goes 1, 2, 3, like this. And this one goes 1, 2, 3, like that. Now we go 1, 2, 3, and down 4. So this new graph is going to look like this. That should be smoother than I drew over there. But all we're doing is we're taking each point and going 3 left, 4 down. Okay. So point A is on the graph of f of x, gets mapped to the point A prime. So this is an image point, x minus 4, y minus 3 on the graph of y equals g of x. So in mapping notation, this is telling us 4 left and 3 down. Okay. So what's g of x actually going to be? If I'm going 4 left, it's going to be f of x plus 4. So this is how we go 4 left in function notation. Plus k is actually going to be a minus 3. Okay. The tricky point here is what's actually our h value. Our h value is not 4, it's actually going to be -4, right? Because if I want to write this guy in the form of f of x minus h, it will be f of x minus -4 minus 3. So that means this is telling us that h equals -4 and that k equals -3. So if I go -4, minus negative 3, well, that answer is negative 1. Okay. All right, so example 7. The domain and range of y equals f of x is domain as x is greater than or equal to negative 4, and the range y is less than or equal to 12. Okay, so really, I don't know what this graph looks like, but I know that we do have a restriction on the domain. So what's what I'm going to quickly do here? We know the graph is bigger than negative 4 and less than 12. So this graph might look something like this. Okay, starting here, this is at negative 4, 12. It goes bigger than negative 4 based on this, and then smaller than 12. So now the question is saying, determine the domain and range of y minus 7 equals f of x minus 9, right? So what would this graph look like? So this is really the same thing if I add a 7 to both sides. F of x minus 9 plus 7. So this is telling us that we're going 9 right, 7 up. So if I go 9 right, 7 up, 9 right is going to go to 5, 7 up is going to go to 19, right? So this would be 5, comma 19, and this graph would be just the same exact shape, just doing this, okay? What's the new domain and range of this? It's x is greater than or equal to 5, y is less than or equal to 19. I'm just going to do this in interval notation here. My domain is from 5 to infinity. My range is from negative infinity to 12, like this. Okay, so I think this should be the answer like that. So this is the answer in interval notation over here. All right, guys, I hope this makes sense for the first topic, which is called horizontal and vertical translations. I'll see you in the next video called reflections and stretches. See you soon.